We already talked a little about complex fractions and how they're really just division within a fraction or fractions within fractions. And what we're going to try this time is just a different strategy. So what we're going to do is we're going to find the LCD of all the individual fractions within the expression, and we're going to just multiply that by everything, and it's just going to make it a lot easier to deal with. So let's try one. Looking at this complex fraction, I have a fraction within a fraction. And the reason it's different than what we did before is you can see I've got several different fractions here, and this one's not even really a fraction because it's a constant. And so what we're going to do is we're going to look at the x and the x and the x squared. We're going to say, how could I make that so that I have a common denominator? Now, instead of changing everything to a common denominator, which is what I could do, I could say, well, let's change this one into 4x over x minus 6 over x. And then the denominator, I'd have to multiply this by x, and that would give me 2x over x squared minus 3 over x squared. But then I would still have some answer here and some answer here, and it would still be a fraction, and I'd still be driving myself crazy. So instead, let's take everything times x squared, because x squared would be the denominator for everything. So if I take this times x squared, I get 4x squared. If I take 6 over x times x squared, think of it as x squared over 1, that would leave me with minus 6x. And look, no more fraction. Now the denominator, if I took x squared times 2 over x, again, think of it as x squared over 1. This one would cancel and leave me with just a 1x left over, so that would be 2x. And then if I took x squared times 3 over x squared, those x squareds would cancel and I would get minus 3. And then I would go from here. So now I still have a fraction, but I don't have 3 or 4 different fractions now. And from here, I know what to do. I know that I can reduce this by taking a 2x out of everything, and that would leave me with 2x minus 3. And in my denominator, I have 2x minus 3. And then, of course, I could reduce and find that my answer is 2x. So instead of doing it kind of the long way, it's kind of like our clearing fractions method that we did solving equations before. So this fraction is a little bit different because we don't have fractions within fractions, except I do have negative exponents. And we all know that x to the negative 1 is simply 1 over x to the first. And x to the negative 2 is simply 1 over x to the second. So I do have fractions, I just don't see them. So the same way that we did the last question where we were looking for that common denominator, that denominator would be x to the second, because this one is x to the first, this is x to the second, x to the first, x to the second, etc. So what if I took everything times x squared? Let's see what happens. I know that when I multiply values that I'm adding exponents. So what's 2 plus negative 1? That's positive 1. So that would give me x to the positive 1, or just x. X squared and x to the negative 2. So 2 plus negative 2 is 0, which gives me x to the 0. What's x to the 0? Well, anything to the 0 is 1. If it makes more sense to you, think of it like this. Because then when I'm multiplying, the first one would reduce, and I would just have x to the first on top. And the second one would reduce, and I would just have 1. For the denominator, that would give me x squared. This one, again, 2 plus negative 1 is positive 1, so that's plus 2x. And for this one, 2 and negative 2 is x to the 0, which is 1, which just leaves me with that minus 3. And then, of course, I would continue to reduce. So the top is x minus 1. X squared plus 2x minus 3 gives me x plus 3, x minus 1. And my x minus 1's cancel to give me 1 over x plus 3. Here's another one with several different denominators. I have a denominator of w plus 3. I have a denominator of w minus 3. I don't have a denominator there, so it's just 1. And this one is actually w plus 3, w minus 3. And so that's my denominator. So I'm going to take everything times that. Every single thing times this. So if I take the first one times w plus 3, w minus 3, those w plus 3's would cancel, and that would leave me with w minus 3. Notice whenever I have a subtraction, I'm going to write the parenthesis. If I took this times w plus 3, w minus 3, the w minus 3's would cancel, and that would leave me with w plus 3. If I took 1 times this, nothing cancels, so I get the whole shebang. And if I took this times the w plus 3, w minus 3, all of that cancels, and I would just get 9. So now I've got a little bit more work to do. On the top, I have a minus on the outside of parentheses, so I'm going to go ahead and distribute that. That gives me w plus negative w, which of course cancels, and then minus 3 plus minus 3, which is of course negative 6. That's my numerator. My denominator, I'm going to have to distribute. I would get w squared minus 3w plus 3w, those go away, and then I have minus 9, and then of course I still have my plus 9. Well, minus 9 plus 9 cancels out, so I have negative 6 over w squared, and that's my answer. Here's one for you to try on your own, so try all of it and then press play to see how you did. Here I would start by looking at my denominator of 1, of y, of 1, and of y squared. So my LCD would be y squared. So I'm going to take everything times y squared. Every single thing times y squared. And whenever I've got a fraction, I just write it over 1. Y squared times y is y to the third. Y squared, that's going to reduce with that 1y here. That leaves me with just 1y, so y cubed minus y. Here, y squared times 1 is y squared. Here, my y squareds cancel, and I just get minus 1. And now I'm going to reduce anything I can. So I'm going to take a y out of both of those. That leaves me with y squared minus 1. And on the bottom, I would factor, but notice I've already got a y squared minus 1 on top and on bottom. And so all of that big mess reduces just to y.